Morning, everyone. Am I audible? Am I audible?
Yes, ma'am.
So today we will start a new topic, and it's unit second from your syllabus. Is correlation analysis. So correlation, it's a statistical technique which is measuring the strength of linear association between the two sets of data. So it may be positive correlation between the data, there may be negative correlation between the data. So positive means when suppose you have a data set, you have two data sets X and Y. If both the data sets moves in the same direction, then we say that the correlation between them is the positive correlation. एक ही डायरेक्शन में मूव होता है जब. And if the data sets are in the opposite direction, suppose we have X and Y data sets and one is moving in the positive and another one is moving in the negative direction, then we say that there is a negative correlation between them. For example, you see that income and consumption. This is the example for positive correlation. Income ज़्यादा होगी तो consumption भी ज़्यादा होगी. So that we have two data sets from income and consumption. So they will always either move in the positive direction or move in the negative direction. So we said that there is a positive correlation between this data set. And if we are talking about like price and demand, and you see that price increases and demand decreases. So there is a negative correlation between these type of data set. And if there exists no relation between the data, absence of any relation between two data sets, absence of any relationship, we say that the zero correlation between them, absence of any relationship between two series. So we say that this is zero correlation. But converse is not also always true. Means if zero correlation exists between, then it's not necessary. There is absence. The data set is independent of each other. So, but not vice versa. So you see that I will share the notes with you and go through all the details. In short, मैंने आपको बता दिया है. So what is the negative and the positive correlation? Means if the data are moving in the same direction, then we have positive, otherwise it's negative. And absence of any relationship, then it is zero correlation. We say that the zero correlation. And this is the example here. And suppose we have two independent data sets and which are analyzed, but instead of getting a zero correlation, we may give a very high degree of correlation. For example, suppose we have a data for the sale of iodized salt and the number of criminals in India during the last 2 decades. So we say that they have gone up, both are in the same direction. So it indicates that the positive correlation, but these two series are actually एब्सोल्युटली इंडिपेंडेंट ऑफ ईच अदर, इन दोनों में कोई रिलेशन ही एग्जिस्ट नहीं कर सकता. सो इस तरीके के कोरिलेशन को वी सेड एट द नॉनसेंस और द स्पिरिचुअस कोरिलेशन, जिनमें दे आर मूविंग इन द सेम डायरेक्शन. It shows that the positive correlation, but the series are independent of each other. So ऐसे relation को बोलते हैं nonsense correlation. So we have some properties for the correlation, like it always lies between +1 to -1. We denoted the correlation by R से इसको डिनोट करते हैं, और जो इसकी वैल्यू होती है वो +1 से -1 के बीच में लाई करती है. इफ इट्स वैल्यू इज +1, देन वी सेड इट परफेक्ट पॉजिटिव कोरिलेशन, एंड इफ इट्स -1, देन इट्स परफेक्ट नेगेटिव कोरिलेशन. नाउ for measuring the coefficient of correlation, there are lots of numerical techniques, but we will study here the two techniques for evaluating the correlation. First one is the Karl-Pearson's coefficient of correlation and the rank coefficient of correlation, and this R denotes the coefficient of correlation. So look at how to evaluate the coefficient of correlation. So first thing is what is the covariance? Covariance, am I audible to you? Voice clear aa rahi hai meri? My voice is clear to you?
Yes, ma'am.
Okay. So variance shows the extent of deviations of the data sets from its mean. And if you remember, we will evaluate variance using the formula. Variance is equals to x minus x bar square by deviations taken from the mean. And square root, sorry. And there is it's also equals to the square root of standard deviation. This sigma denotes the standard deviation. So this is the formula for evaluating the variance and the standard deviation. So now we are talking about the covariance. Variance shows the extent of deviations of data sets from its mean and variance in two data sets from the respective means is known as covariance. So we evaluating the covariance using this formula. This is from the two data sets x and y. So it's equals to summation of x minus x bar, summation multiplication with y minus y bar divided by n. And we have again the properties for the covariance. It can be positive or the negative. If both the data sets move in the same direction, then covariance is positive. And if the values are moving in the opposite direction, then covariance is negative. And if the value of covariance is 0, agar 0 aa jati hai, then we say that the series are independent of each other. Now in the problem, we will see that how can we evaluate the covariance between the data. So look at the problem here. See the problem. Question here is, we have a sample of 8 students of an undergraduate class was taken and the marks of mathematics in class 10th and 12th were noted. So this is the sample of 8 students of their marks in mathematics class 10th and class 12th. Find from the above data, calculate the covariance and interpret the results. So you know that covariance is equal to, मैंने क्या बताया अभी? How can we evaluate covariance? Covariance between two data sets is equals to x minus x bar, y minus y bar divided by n. So value of n is here, and x is given, y is given. In order to evaluate the covariance, you need the difference between x minus x bar and y minus 1, summation of x minus x bar and the y minus y bar. So first find out the mean for the data set of x. Mean is equals to x bar is equals to summation of x by n, y bar is equals to summation of y by n. So we have evaluated the sum of x and the y. And then evaluating the deviations from mean. Deviations from mean in case of y, product of x minus x bar and y minus y bar, because it's required for evaluating the covariance here. And find out its sum. And after evaluating the sum, you substitute it in the covariance formula. Summation of x minus x bar, y minus y bar by n. So you get 41.5 marks. So it indicates the positive association between the marks of two classes. That's it. Is it clear how to evaluate the covariance? कैसे evaluate करना है? Two data sets अगर मुझे given है तो please let me know. This is clear, or I need to repeat it again? Is this clear? Yes or no?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Fine. So this is the method for evaluating the covariance, which is equal to summation of x minus x bar, y minus y bar divided by n. Okay, you just need to remember this formula for evaluating covariance. अगर covariance में दोनों series और ऐसे एक डायरेक्शन में मूव करती है तो वो पॉजिटिव होता है, अपोजिट डायरेक्शन में मूव करती है तो नेगेटिव होता है. Now come to the measures for the coefficient of correlation. So first technique here is the Karl-Pearson's coefficient of correlation. It was given by Karl-Pearson's, so it's named as Karl-Pearson's coefficient of correlation. This is, and second one is the rank coefficient of correlation. We have some properties for the correlations. So here you see that the properties for the correlation. So the first property here is it measures the linear association and it does not explain the non-linear relationship between, will be the linear association between variables. Second property is it is independent of origin or scale. Means अगर मैं इसके data set में कुछ भी positive, कुछ भी multiply, divide and add, subtract कर दूँ तो उसका correlation पर कोई भी impact नहीं पड़ता. It is independent of origin and scale. It's also the very important property here. The value of correlation lies between +1 to -1. मैंने पहले भी बता दिया है कि अगर -1 होती है we called it the perfect negative correlation, or +1 होती है then perfect positive correlation. If R is equals to 0, then data is independent of each other, but converse is not true. This is the other property. Two data sets are random variables. Data are normally distributed, and it does not necessarily explain cause the effect relationship. Conditional variance of one variable given the other is identical. So these are some properties for the correlations. And in this example, you see that is the following statement true or false? So question here is, if the coefficient of correlation between two variables is 0.8, then coefficient of correlation between -x and -y is minus 0.8. So it's wrong because we are saying that it is independent of origin and scale. तो अगर मैं wait a minute please. Hello. हाँ ठीक है ओके. Please call me later, maybe class is going on. ठीक है ना, मैसेज ड्रॉप कर दो. कॉल मी लेटर. हाँ ठीक है. So if the coefficient of correlation between two variables is 0.8, then the coefficient of correlation between minus n and minus x, it will remain 0.8. It will not be minus 0.8 because R is independent of change of origin and scale. तो अगर मैं किसी डेटा सेट में कुछ भी मल्टीप्लाई कर दूं तो उसका correlation पे कोई भी impact नहीं पड़ेगा. Correlation between the variables will always be same. So these are the properties for the correlation here. Now next, see that how to evaluate the correlation, Karl Pearson's coefficient of correlation between the given data. So in this data set, it is also known as Karl Pearson को बोलते हैं product moment correlation भी बोलते हैं, product moment correlation, and it's equal to covariance divided by sigma x sigma y. Sigma x represents the standard deviation of x and sigma y represents the standard deviation from y. So if we substitute the formula for the covariance here, covariance को evaluate करने का हमने formula आपको बताया था, summation of x minus x bar y minus y bar divided by n. So simply एक फॉर्मूला मेरे पास ये हो गया अगर कोवेरियंस और स्टैंडर्ड डेविएशन गिवन है. अगर डेटा सेट गिवन है डायरेक्टली, सो यू कैन सब्स्टिट्यूट द फॉर्मूला हियर. सो दिस इज द सेकंड फॉर्मूला फॉर इवैल्यूएटिंग, एंड if we have substitute the value of standard deviation is equals to square root of x minus x bar square by n. तो अगर मैं इसको सब्स्टिट्यूट कर दूं, so we have obtained this form, summation of x minus x bar y minus y bar square root of x minus x bar square y minus y bar square. So these are the formulas for evaluating the coefficient of correlation. और अगर मैं इस होल स्क्वायर को इवैल्यूएट कर दूं, समटाइम्स कभी कभी हम क्या करते हैं कि इस फॉर्म को भी यूज कर लेते हैं. अगर होल स्क्वायर को मैं इवैल्यूएट कर देती हूँ, सो दिस फॉर्म्स कन्वर्टेड इनटू दिस फॉर्म. प्रॉब्लम में जब हम करेंगे तो जो भी मेरे को कंफर्टेबल और रिक्वायर्ड फॉर्म लगेगी मैं उसको यूज करूंगी. कभी मैं इसको भी यूज कर सकती हूँ और इसको भी यूज कर सकती हूँ. इट्स अप टू यू. And this is the formula for in case of the deviations. कभी कभी डेटा सेट बहुत कॉम्प्लिकेटेड और लेंथी होता है तो हम क्या करते हैं, assumed mean से deviations evaluate करते हैं. जैसे कि अर्थमेटिक मीन आपने पढ़ा होगा, उसमें भी हम deviations एक assumed mean consider कर लेते हैं और उसके बाद हम इसको evaluate करते हैं. So dx represents the assumed mean and dy is the deviations which are taken from the assumed mean. So this is also the other method for evaluating the coefficient of correlation. So these are the 3 and 4 formulas for evaluating the Karl Pearson's coefficient of correlation. ये मैंने अभी आपको बता दिया. It is independent of origin and scale. If the value is +1, then perfect positive correlation. If it's -1, then perfect negative correlation. R is equals to 0 indicates no correlation, means the series are independent of each other. Is this okay? Let's see the problem. किसी को कोई प्रॉब्लम है यहाँ तक? Can we take a problem based on correlation?
Yes, ma'am.
So look at the example number 3 here. The following table gives the demand and price figures for a commodity for 6 days, and you have to calculate correlation coefficient between price and demand. One more thing, agar mentioned nahi hai method, then go for the Karl Pearson's coefficient of correlation, or by name aata hai, then go for rank correlation only. Okay, so this is the data set here between the price and demand Monday to Saturday, right? And what conclusion do you draw from the result? This is our question. So days are taken as Monday to Saturday and price and demand. So this is the value for X and this is denotes the value for Y. This is X and this is Y. Now, formula for evaluating the Karl Pearson's coefficient of correlation is summation of X minus X bar, Y minus Y bar and summation X sigma Y. ये मेरे पास फॉर्मूला है एंड या तो हम इसको यूज कर सकते हैं या फिर आप इसको यूज कर लो, स्टैंडर्ड डेविएशन इवैल्यूएट करना ही पड़ेगा. तो समीशन स्क्वायर रूट ऑफ x माइनस x बार स्क्वायर स्क्वायर रूट ऑफ y माइनस y बार स्क्वायर. So we need the deviations from mean, some of the deviations from mean. So first thing is evaluating the mean. Mean means mean means x bar is equals to summation of x by n, y bar is equals to summation of y by n. So we have evaluating summation of x. So it's 120 by 6, which is 20, and summation of y is 108 by 6, that's 18. Now next step, find out its deviations. Then the product of x minus x bar and y minus y bar. Whatever we required for the formula. Formula is summation of x minus x bar, y minus y bar, square root of summation of x minus x bar square and summation of y minus y bar square. तो मुझे एक तो इनका प्रोडक्ट चाहिए, नेक्स्ट में मैंने इनका प्रोडक्ट इवैल्यूएट करा है और इसका होल स्क्वायर चाहिए. इन दिस कॉलम वी हैव इवैल्यूएटिंग द होल स्क्वायर. फाइंड आउट इट्स समीशन. ये तीनों के हमने समीशन यहाँ पर सम इवैल्यूएट करा है एंड सब्स्टिट्यूट इट इन द फॉर्मूला. तो यू सी दैट ये हमने इसको इवैल्यूएट कर लिया कंप्लीटली, सब्स्टिट्यूटेड इन द फॉर्मूला, एंड आफ्टर इवैल्यूएटिंग we have obtained the value of correlation is minus 0.886. So it indicates that they are negatively correlated in this example, right? Price and demands are negatively correlated क्योंकि ये negative आ गया है यहाँ पे. And one more thing, it lies between +1 to -1 always. Is this clear? Is this clear?
Yes, ma'am.
It is very simple, सिर्फ फॉर्मूला बेस्ड है. कॉरिलेशन इवैल्यूएट करने का या तो आप इसको यूज कर सकते हो, अगर कोवेरियंस गिवन था, ये स्टैंडर्ड डेविएशन प्रॉब्लम में डायरेक्टली गिवन है तो हम इसको यूज कर सकते हैं. अदरवाइज हम इस फॉर्मूले को यूज करेंगे, थर्ड वन. और अगर मुझे लगता है कि होल एक्स स्क्वायर इवैल्यूएट करना ज्यादा सिंपल लग रहा है तो आप इसको इवैल्यूएट यूज कर सकते हो. जैसा कि अभी इसके बाद वाली प्रॉब्लम में इस फोर्थ फॉर्मूला को हमने evaluate करा है. If 2 series is not in the integers, then this one is the easiest way to evaluate. Like in this example, you have to evaluate the correlation coefficient. X और Y ये data set दे रखा है. Let now each value of X is multiplied by 2. and then 6 is added to it. Similarly, each series of y is multiplied by 3 and 2 is subtracted. What will be the correlation coefficient between the new series? So we have said that correlation is independent of origin or scale. कोई impact नहीं पड़ेगा, जो इस डेटा से निकल कर आएगा वही उस डेटा से आएगा. इसका solution तो मुझे पता चल गया. It will be remain same because it is independent of origin and scale. इस वाले प्रॉब्लम को सॉल्व करने के लिए जो थर्ड फॉर्म है हमारे पास कॉरिलेशन इवैल्यूएट करने की, दिस इज द फॉर्मूला, ये यूज करा गया है, राइट. तो वी नीड इन दिस फॉर्मूला वी नीड समीशन ऑफ एक्स वाई की प्रोडक्ट निकाल ली, एक्स स्क्वायर चाहिए और वाई स्क्वायर चाहिए, ये सबका समीशन निकाल दिया एंड देन सब्स्टिट्यूट इट इन द फॉर्मूला, सिंपल. So you have obtained the value 0.949 here, and it shows that the positive correlation. And in this part, data set में चाहे कुछ add करें चाहे कुछ subtract करें, क्योंकि we have a property here that correlation is independent of origin and scale. So correlation पे कोई impact ही नहीं पड़ेगा. It will remain same. So although you can evaluate, इसको पहले वाले मेथड से भी कर सकते हैं, but you find that this is the simplest way, तो हमने इसको यहाँ पर यूज कर लिया. Both are the same thing. Is that okay? Next, I'm taking one more problem. Question here is, covariance between x and y दिया हुआ है -15, मीन ऑफ x दे रखा है 20, मीन ऑफ y दे रखा है 16, and coefficient of variation of x is 25%. ये दिया हुआ है, and you have to evaluate, find Pearson coefficient of correlation. Coefficient of variation evaluate करने का जो फॉर्मूला होता है, it is sigma by x bar multiplied by 100, ये होता है. So now we have coefficient R is equals to covariance of xy divided by summation of x, standard deviation of x and standard deviation of y. So you simply evaluate it now. ठीक है, सारा डेटा सेट मेरे पास गिवन है और मुझे इससे इवैल्यूएट करना है. Is that okay?
Yes, ma'am.
आप इसको मेरे पास y के लिए भी है x के लिए भी है, तो एक बार स्टैंडर्ड डेविएशन x के लिए निकल जाएगा, एक बार y के लिए निकल जाएगा. So you just do it yourself. In the same way, suppose एक और प्रॉब्लम मैं यहाँ पे लिख देती हूँ. समीशन ऑफ एक्स वाई इज इक्वल्स टू, कभी कभी ऐसे डेटा सेट्स दे देते हैं, so you just simply apply the formula. n equals to 100, समीशन ऑफ एक्स स्क्वायर मुझे दे दिया गया 80, समीशन ऑफ वाई स्क्वायर दे दिया गया 20. फाइंड आर। तो कौन सा फॉर्मूला हम यूज करेंगे यहाँ पे? ये वाला, क्योंकि समीशन ऑफ एक्स दे रखा है, एक्स स्क्वायर दे रखा है, एन दे रखा है, सो अप्लाई दिस वन, राइट? You can obtain the value for coefficient of correlation. It depends on which type of data is given in the problem. One more problem. Calculate the Carl Pearson's coefficient of correlation between expenditure on advertising and sales from the data given below. ठीक है, ये डेटा सेट मुझे दिया हुआ है यहाँ पे 36 एंड 78, एक और डेटा यहाँ पर 60, 91, 51 एंड 84, राइट? तो इस वाले क्वेश्चन को आप करो डेविएशंस वाले फॉर्मूले से। डेविएशंस मींस फॉर्मूला मेरे पास है डेविएशंस वाला, समीशन ऑफ dx dy बाय n, x की जगह डेविएशंस आ गया बस, d स्क्वायर x समीशन ऑफ dx होल स्क्वायर बाय n summation of d square by dy square by n. Now you need this dx and dy. Dx is equals to x minus assumed mean. तो हमने यहाँ पर जो मीन assumed करा है assume mean 65 and 68. ये जो आपको डेटा सीरीज यहाँ पर दे रखी है, ठीक है, इससे मीन इवैल्यूएट करो आप, ठीक है, एंड टेक इट द डेविएशन. सो वी हैव टेकन द एज्यूम मीन हियर 65 एंड dy इज इक्वल्स टू x माइनस 68. तो एक मेथड इवैल्यूएट करने का ये भी होता है, या तो आप x माइनस एक्स बार कर लो, या फिर हम एक मीन इसमें से सीरीज में से एज्यूम्ड कर लें जो मुझे लगता हो कि मेरे को सिंपलेस्ट वे में चेंज कर देगा प्रॉब्लम को. सो इस मेथड से भी हम इसको इवैल्यूएट कर सकते हैं. दिस इज एज्यूम्ड मीन. Assume mean from y. So you just try to find out. एक कॉलम मेरे पास यहाँ पे सेम बनेगा, सिर्फ इसी प्रॉब्लम में पहले वाली प्रॉब्लम यहाँ पे यस x माइनस एज्यूम मीन, y माइनस एज्यूम मीन एंड सेम यही चल रहेगा, बस एज्यूम मीन से हमने इसको डिवाइड सब्ट्रैक्ट किया है. Try to solve the problems, and in the next class we will continue on rank correlation and regression analysis, right? तो इसको आप करो तब तक. Whatever the book you have, you try to solve maximum number of problems. Any problem? किसी को? किसी को कोई प्रॉब्लम? Is this clear? Please write down the attendance. Is this clear or any problem? Clear to all? Yes or no?
Yes, ma'am.
Okay. So next class में हम rank correlation continue करेंगे. Okay.